video is for the domain and range in various forms of exponential functions. So we're going to look at infinite and finite functions. So our first one here is an infinite function. F of x equals 2 to the x plus 1. And so our domain and range here. So we've got arrows. I know they're hard to see here, but we've got arrows on both ends of this, meaning that our domain is all real numbers. Now, our range is always going to be from this horizontal asymptote up or down. So in this case, we're above it, and that asymptote is y equals 1. So our range is going to be all real numbers greater than 1. All right, so now we can start writing them in the different forms. So all real numbers in interval notation is from negative infinity to infinity. And then our range is going to be from 1 to infinity. And I use the parentheses here because it's greater than, not equal to 1. It's always going to be bigger than that 1. In inequality notation, we would just write x as a member of the set of all real numbers. And for the range, y is greater than 1. And then in set notation, we would just write x as a member of the set of all real numbers. And then y is a member of the set of all real numbers, where y is greater than 1. All right, so for the your turn part, same thing. This is an infinite, so we've got arrows at both ends. So the verbal is still going to be all real numbers. This time, though, our asymptote is y equals 2. So our range is going to be all real numbers greater than 2. So in interval notation, from negative infinity to positive infinity, and from 2 to infinity for the range. In inequality notation, x is a member of the set of all real numbers, and y is greater than 2. And then set notation is the same way, except for the range, where it's going to be y is a member of the set of all real numbers, where y is greater than 2. Okay, so now for a finite. What we have here, we've got a solid dot, and then we've got an arrow here. So our domain here, we are starting at negative 1. It's a filled-in dot, so it's greater than or equal to 1. So we would have all real numbers greater than or equal to negative 1. So our range here, so our top value here is this 6, and our bottom value is this 2. So remember your asymptote, it's never going to be equal to that number. So our range would be all real numbers greater than 2 or less than or equal to 6. So in interval notation, we would use a bracket for the negative 1, and then it's going to go to infinity. For the range, we would use a parenthesis for the 2 and a bracket for the 6. As an inequality, x is going to be greater than or equal to negative 1. For the y, 2 is less than y is less than or equal to 6. And then in set notation, x is a member of the set of all real numbers where x is greater than or equal to -1. And then y is a member of the set of all real numbers where 2 is less than y is less than or equal to 6. All right, on the your turn. So we've got an arrow on the left and an open circle on the right. So I'm starting at -infinity. It's going to go on and on forever to -infinity. But my x's are going to end at 2. So my domain is going to be all real numbers less than 2. My range, my high point is this 10. My low point is this 1. Again, we've got an open circle. So all real numbers greater than 1 and less than 10. All right, so in interval notation, we're going to go from -infinity to 2. For the range, from 1 to 10. In inequality notation, x is less than 2, and 1 is less than y is less than 10. And then in set notation, x is a member of the set of all real numbers where x is less than 2. And in the range, y is a member of the set of all real numbers where 1 is less than y is less than 10.